Hi there. Today we're going to talk about square roots. This is something that we're going to use in the next chapter within geometry, so we're going to take a day and kind of review this, make sure you remember this from algebra. And we're going to do several things with square roots. We're going to start off just by simplifying them, and to that we just mean we want to make the number that's in the radical as small as possible, and maybe even not even have a radical if it will reduce that nicely, which is where I start right here. There are some numbers that you can take the square root of and they just come out clean, there's no radical left. If you take the square root of a perfect square, which I've given us a list of all the perfect squares over here, if you take the square root of any of these numbers, then you're going to get a nice rational number for an answer. So let's just run through real quick. The square root of 49, anytime I see the square root of 49, I'm going to say, oh, that's 7. Square root of 36, that's 6. Square root of 4 is 2, and so forth. So we have to know these numbers, and that's kind of our goal, is to try to get these numbers underneath the radical, because I know they're going to come out clean and rational. So let's look at what do you do then to reduce a radical that is not a perfect square. For example, this one that has the square root of 45. That's not a perfect square. It's not in my list over here. But what I can do is I can break that down into the product of two radicals, as long as those multiply to 45. Now, I could pick a variety of options here. I chose 9 and 5. It could be 15 and 3. But my goal is to try to pick a number that is a perfect square. If I can pull a perfect square, well, that's going to come out nice. So that goes to 3. And then I'm left with the square root of 5. That doesn't come out nice, and it's just going to stay inside the radical. But my number underneath the radical, we call that the radicand, that is much smaller than it started off with. Okay, so if you look at this one, the square root of 32. All right, I'm going to break that down to the square root of 16 times the square root of 2. The square root of 16 is a perfect square, so that's going to be 4, and the square root of 2 stays put. All right, how about the square root of 20? You're going to multiply two numbers together to get 20, but one of them has to come from our list of perfect squares. We should be choosing 4 and 5. The square root of 4 is 2. Square root of 5 stays underneath that radical there. All right, so let's keep practicing. Square root of 50. Now, when we were choosing that perfect square, we always want to be sure that we pick the largest perfect square. On that previous problem where I did 32, you might have thought 4 and 8 would work. It would, but it wouldn't have been reduced as small as it could. So always pick the largest perfect square. In this case, I'm going to go 25 times 2. Square root of 25 is 5. Square root of 2 stays put. Here we have 40. I'm thinking 4, but anytime 4 goes into it, I typically will check 16, because 16 sometimes then goes into it. In this case, that's not going to work, so I'm going to stick with my 4 and my 10. Square root of 4 is 2. Square root of 10 stays under the radical there. All right, here's square root of 80. Again, 4 would go into that, but like I said, I would try 16. And actually in this example, 16 does go into it, so we want to choose 16 times 5. And then the square root of 16 is 4, square root of 5. All right, here we have the square root of 18. What do you think the perfect square is that goes into that? 9 times 2. All right, square root of 9 is 3. Square root of 2 stays put. This is just reducing radicals here. And I just pulled these notes actually just from my Algebra 1 class, so they're going to mostly match what you have in front of you. They might be a little bit different. All right, what's new now is I'm going to throw a coefficient on this radical. And I ultimately just drag that coefficient down and kind of ignore it for now. It's just going to be sitting here. Remember that you're just multiplying all these things together. So I'm going to work on my radical. I'm going to break it down to square root of 5 and square root of 3, or 25, sorry. And then the point of choosing 25 is because it's going to come out nice. And then I have my square root of 3 still here. And this is the extra step. Well, if I've got these two numbers being multiplied, I can go ahead and multiply them. You can multiply like things. You can multiply if they're both outside the radical, they get to multiply. If they're both inside the radical, but you can't do one of each. Number 2. 6 square root of 18, choosing the perfect square that goes into that, it'd be 9 times 2. You always want to put your perfect square number first because you know that it's going to come out nice and might have to get multiplied. We want to keep those parts together, so the perfect square always goes in the first radical. And I'm left with 18 square root of 2. Is this ringing a bell from Algebra 1? All right, a couple more here. This first one's kind of weird because I'm sitting there thinking, okay, what goes into 36? Well, actually, 36 is in my list. So don't make this harder than it has to be. If I happen to, and I will, throw a perfect square at you every once in a while, that just comes out to 6. And multiply it by my 6. And so my answer is 60. No radical at all because the radical they had was a perfect square. Not so lucky on this one. I'm back to figuring out what would go into 150, and I think I'm going to go with 25. And that goes in there 6 times. The square root of 25 will come out nice. The square root of 6 stays put. All right, then we're going to do some multiplying of radicals. And like I said earlier, you can multiply like things. So in this first example, since both of these are underneath the radical, they actually get to multiply together and they stay underneath the radical. This is just going to be the square root of 15. You multiply them together. Look at this number 2. This is just going to end up being the square root of 20. But here's the deal. I am going to multiply them together, but I'm going to then look to try to reduce them. They had chosen 2 and 20 as the two numbers that multiplied. 2 and 10 are the two numbers that multiply to 20. But I could pick a better set of factors. Wouldn't 4 times 5 get me 20? And if I choose 4, it's from my list. 2 and 10 were not, so they weren't really helping. I'm going to go with the square root of 4 times the square root of 5. The square root of 4 is just 2, and then I leave my square root of 5. You're going to multiply these together and then try to re-break them down in a better way. Let's try number 3. 5 times 15. That is the square root of 75. And then I know I can break down the square root of 75. I end up with 5 square root of 3 for a final answer on that one. All right, take a peek at number 4 here. This is weird. I'm multiplying two radicals and they're identical to each other. Well, that would end up giving me the square root of 4, and 4 is in my list of perfect squares. This answer is just going to come out nice as a rational number. It's a 2. Square root of 4 is 2. Not square root of 2, just 2. That's actually going to happen every single time that you try to multiply two identical radicals, because you're going to multiply these two. You're basically squaring that number. This will always end up a perfect square, and then when you square root it, you're back to that number. So keep that in mind for future. If I take the square root of 10 times the square root of 10, that's going to ultimately just get me 10, because it's the square root of 100, which breaks back down. If I did the square root of 7 times the square root of 7, I'm going to get just 7. We're going to use that handy feature later on. All right, a little bit more multiplying, different things happening on this. Now all of a sudden I have a coefficient on each one of my radicals. Again, we're going to multiply like parts, so we can multiply the negative 5s, and then we can multiply the radicals. A negative 5 times a negative 5 is 25, and then when I multiply my radicals, I'll have a square root of 6. The square root of 6 is not going to reduce for me, so I get to be done right there. Next problem. Multiply the coefficients, negative 2 times 3. Multiply the radicals, square root of 16. And then I'm going to look to reduce that square root of 16. Happens to be in my list, which means that's going to come out nice, and I don't have any radical at all in my answer. All right, number 11, we assume this is like a negative 1 that's sitting in front of that. that gets us a positive 4 when we multiply square root of 18. And then I look at my list and say, what goes into 18? I'm going to go ahead and just bring the 4 down. Don't do anything with it yet. But then I'm going to go square root, and I'm going to choose 9 and 2. That's 4 times 3 times the square root of 2. I would get 12 root 2 for that answer. Why don't you try that last one? Multiplying the coefficients gets me a 10, square root of 24. The square root of 24 will reduce when I look at my list. 4 goes into that, so I'll go 4 and 6. That's a 10 times a 2 times the square root of 6, which ends up at 20 root 6. All right, so we're going to take a break now, and or we at least we did in class, and I went ahead and had them take their homework and sit there and just work on the front page, front and back of the first page, and work on just the odds, practice this stuff that we're doing right here before we move on to the next stage where it gets a little bit more complicated. Make sure we're comfortable with this before we move on. So I guess my suggestion is pause the video, go work on that first page, front and back, just work through some odds, make sure you're good there before you continue the video. All right, so coming back now, all we're going to do is divide radicals. That's the last thing then that we have to add in. And this dividing radicals is ultimately the reason we're doing this is because in geometry we need to be able to divide radicals. This is how that's going to work. You're going to have a square root over a square root. In this case, I've got the root 15 over the root 35. You can reduce these radicals the same way you would a fraction if it was 15/35. You know, it's like I'm breaking this down into a product of 2 radicals, and here too, and these square root of 5s will cancel out. So I'm left with the square root of 3 over the square root of 7. Now I'm probably not going to show that step of work every time. I'm just going to look at my 15/35 and try to figure out how that would reduce, and then leave radicals on what needs to have radicals. All right, so let's practice that a little bit. I'm going to take my 15 and my 6 and say what goes into both of those. 3 does. If I divide them each by 3, I'm left with this right here. 18 and 10. What reduces there? Well, they're both even numbers. 2 goes into both. So I'm going to have the square root of 9 over the square root of 5. Now what's different suddenly about this one is this square root of 9 that I have on top actually reduces. Square root of 9, that's going to end up a perfect square, giving me just 3 over root 5. If you can reduce, you want to go ahead and try to reduce. This last one, I threw a coefficient on the front, and you can reduce those the same way you always would. A 4 over 2, that's going to become 2 over 1. Let's see, 18 and 6. 6 goes into both of those. Oh, that's weird. Think about this. What you would do is that would turn into a 1, and that'd turn into a 3. I know in my numerator I'm going to have the square root of 3, but in the denominator the square root of 1 is just 1. So there's not really even any reason to write it. There's no reason really that I wrote this one. I don't think I even need to write this as a fraction. It's all over 1. I think the star here was just about reducing your 9, so you can ignore that. All right, let's practice that one more time. And actually on this one, I have you doing this on your own. Can you try to reduce these 2 problems? Go ahead and pause the video and take a moment to do these 2 on your own, and then come back. All right, here's what I've got. Check your answers. If you agree, let's move on. If not, take a minute and see if you can get yours to match mine. All right, and this right here, again, this goes back to my Algebra 1 class. Don't worry about that. Don't do that right now. Let's keep moving. All right, so the last thing here is that, we were just practicing dividing by radicals, but we're a little bit picky as mathematicians on how we write some things, and we like to keep our denominator a rational number. And if you have a radical in the denominator, radical square roots, those are irrational numbers. And so we want to do what we call rationalize the denominator. Make the denominator a nice clean number. If I'm going to have a square root, I want it up in the numerator. All right, here's kind of our three-step process. First thing you're going to do is try to reduce the fraction that they give you, try to get your numbers smaller. That's what we just got done doing. We did step one. Then what you're going to do is you're going to multiply your numerator and your denominator by whatever radical is in the denominator. So if you had something like 5 over root 2, I would multiply by the radical in the denominator. It would look like this. You want to do it at the top and the bottom, just like if you were getting a common denominator or something, you're multiplying by the same thing on the top and the bottom. And right here, this is the deal we were talking about earlier. If you multiply two radicals that are identical to each other, you're going to get this perfect square under there that's going to square root nicely. Now in the top, I just have a 5 root 2. There's nothing I can do there. But in the bottom, I'm going to end up with this root 4 that comes out clean to a 2. So that kind of there, that's what we're doing. And then my last step is to simplify. I box that in, but sometimes you can simplify here or do some sort of further simplification to get your numbers smaller. All right, let's practice a little bit. All right, so looking at this, first step, clean it up if you can, simplify. This one doesn't. And then you multiply the top and the bottom by that radical. I'm going to have 9 square root of 2 all over 2. Look to reduce the 9 and 2. It doesn't. I'm done. Okay, let's try again. First thing, try to reduce something, but the 20 is outside the radical, the 6 is inside, I can't reduce. Go ahead and jump in and multiply by your denominator. I'm left with 20 square root of 6 all over 6. Now here I do get to reduce, not the 6's because one's in the radical and one's not, but the 20 over 6, that part, those are both outside the radical, so those can reduce. 4 goes into both, oh no, it doesn't, 2 goes into both of those, so 10 and a 3, and that square root of 6 is not part of that reducing, it just stays square root of 6. And I've got it. So this is kind of what we're doing. This last part here, this is the last thing we're doing, is just trying to rationalize a denominator. All right. You do want to simplify first. This one actually does have some simplifying because these radicals could reduce. I'm going to go ahead and call that 3. And then this would just become a 1, so I'm not going to bother to write it, but that would become a 5. But it's underneath the radical. So like that. All right, got it, my number smaller. Now I'm ready to rationalize, so I multiply by that radical that's in the denominator. In the bottom, I'm going to end up with just a plain old 5. Take a minute there to decide, will this reduce? The 3/5 does not, and the 5s can't because one's in the radical and one's out. Oops. There you go. Last problem. Can't reduce anything because one's in the radical, one's not. I'm going to multiply by the square root of 8, square root of 8. I get 20 square root of 8 all over 8. Now there's a couple things here. Did you catch that the square root of 8 actually reduces? That's not the smallest number I could have inside my radical. I could definitely reduce that. So I'm going to look at that like 20, and then I'm going to break that down square root of 4 times square root of 2. Now I could be doing some reducing, but I'm going to wait here at till the end. Ultimately, this square root of 4 is going to be up 2. That's got my number smaller under the radical. I have 20 times 2 right here. 20 times 2 is 40, and then I have that square root of 2 still sitting out to the side. Divide by 8. All right, I've got the radical out of the denominator. I just need to reduce right here. That would just reduce to a 5. No need to even write this as a fraction. It's just going to be 5 square root of 2. All right, that's all I have for you. The last page of your homework is doing this dividing and rationalizing your denominator. It says finish the homework worksheet, all problems. So go back, if you only did the odds there at the beginning, we're doing, for your homework, you're going to have the whole thing done. So go ahead and do your evens and finish up the back page. All right, hope this helps. Good luck.